This is part two of the existence of God. Here we are providing additional argumentation that the God of the theistic worldview exists. In the previous part, we dealt with the vertical cosmological argument from the Thomistic tradition and argued for the existence of the Christian theistic God. Here we'll be using the horizontal argument, or what is popularly known as the Kalam cosmological argument, to additionally argue or give a second argument for the existence of the theistic Christian God. Our objectives is to explain how the Kalam cosmological argument demonstrates that the Christian God exists, and two, to answer various objections to arguments for the Christian God, particularly as they are leveled against the Kalam cosmological argument. The Kalam cosmological argument is quite old, dating back to medieval Islamic scholars. Christian scholar Saint Bonaventure used the argument from 1224 to 1274 he lived. It was taken and adapted from some of the points that Aristotle made by medieval Islamic scholars. Today, perhaps the most prominent proponent of this argument is apologist William Lane Craig, who wrote the Kalam cosmological argument in 1979. The argument has tremendous value and importance to establishing Christian theism. In fact, I find most who will debate Christian apologetics and put in the position of having to prove the existence of God will, in all likelihood, use some aspects of this argument or use the argument itself. It's very valuable. It's very simple and straightforward, and you can give simple presentations of it to popular lay-level type audiences. You can give very complex and intricate presentations relevant to scholars in academia as well, depending on who you're talking to. But the same basic outline of the argument is as follows. Everything that begins to exist has a cause of its existence. The universe began to exist. Therefore, the universe has a cause of its existence. Now, the first will defend each premise of the argument, and if premise 1 and premise 2 are true, that is, that they're sound, they correspond to reality, then the conclusion naturally follows. There's no fallacies, formal or informal, with respect to the argument. Again, it's up to establishing premise 1 and 2, and then therefore the conclusion naturally follows. You can also diagram it this way, for those that want to see it more visually. You can start with the universe. Either it had a beginning or it had no beginning. If it had a beginning, either it was caused or it was not caused. We would be arguing that the universe did indeed have a beginning, and therefore it was caused to exist. So let's start with the first premise, that everything that begins to exist has a cause. You would think that this would have little challenge out there, but actually there have been a number of challenges, especially from atheists, that have been put forward with respect to this issue. But before looking at the challenges, let's look at the correspondence or the soundness of it. First of all, we have to note that this is a metaphysical assertion, that something cannot come into being from nothing or from non-being. Many times people want to put this into the context of science or perhaps even some other discipline, as we'll see in the objections. But we have to note that this is really a metaphysical assertion. This is beyond the physical, and it describes being and non-being. And it says that being cannot come from non-being. If it begins to exist, if it's the kind of being that begins to exist, then it must have a cause to its existence. If the reverse is true, in a metaphysical sense, that things can come into being from nothing, then there's really no explanation as to why it doesn't happen more frequently or more often. Why did it just happen with respect to the universe itself? Why don't we have the experience of tigers appearing out of nowhere and attacking people? Well, this kind of thing just doesn't happen. It's contrary to our experience. That being the case, it seems to follow from experience as well as the metaphysical assertion that everything that begins to exist has a cause. Now, this argument, again, has some objections. First, we'll look at some philosophical objections to this particular argument. But let me also note, even before we take a look at that, that some simply misstate the first premise. In fact, Daniel Dennett, in his Breaking the Spell, one of the new members of the popular atheist movement that exists today, in his book Breaking the Spell, simply just misstates the first premise. He says that everything that exists must have a cause. And hence he says, well, then what caused God? But that's just a misstatement. You'll notice it doesn't say that. It doesn't say everything that exists needs a cause. This is a popular misstatement of all the cosmological arguments dating all the way back to Immanuel Kant. That is not the principle of causality or the principle of sufficient reason that we're asserting here. We're asserting that everything that begins to exist has a cause, not that everything needs a cause. But that misstatement aside, the philosophical objection comes from J.L. Mackie, where he appeals to the fact that God needs a cause, and God has existed for an eternal amount of time. That being the case, then we're just needing to rephrase the argument or apply the argument back to God. But this is not an objection to our principle that we're asserting here. As we'll show later on, that there is really a third option, that God is beyond time and hence he is uncaused. Now this certainly may be a mystery to us. There may be hidden aspects as to how this could be, but it's certainly not intelligible that God is beyond time or prior to time or timeless, and that the universe involved the beginning of the space-time universe. So again, while this is an objection that's put here with respect to the argument by J.L. Mackie, it's not really an attack on our principle itself. Second, Mackie will come forth and appeal to David Hume with respect to the principle. He'll say that David Hume said, we can certainly conceive of an uncaused beginning to be of an object. If what we can thus conceive is nonetheless in some way impossible, this still requires to be shown. But what's being missed here is the notion of it being conceived, that is, imagined. We can certainly imagine that tigers appear out of nowhere and then attack people, but imagining that something can do that, that a tiger can do that, is quite a bit different than proving that it actually happens in reality. So the fact that we can conceive of certain things is quite different from actually demonstrating that to be the case in reality. In fact, in 1754, a letter that David Hume wrote to John Stuart basically revealed this fact. He says, but allow me to tell you, this is David Hume saying, but allow me to tell you that I never asserted so absurd a proposition as that anything might arise without a cause. I only maintain that our certainty of the falsehood of the proposition proceeded neither from intuition nor demonstration, but from another source. So even here, David Hume is not saying or making the assertion contrary to our first premise that everything that begins to exist has a cause. He's not countering that in any way whatsoever, especially as it is applied to reality. So I don't think that there's any legitimate objection to this, philosophical or otherwise. It is a first principle. It merely needs to be explained in order for it to be defended. Now, there are some scientific objections that have been put forth to this. Now, the first problem with even putting a scientific objection to this is identifying the fact that this isn't a scientific statement. This is not something that is applicable to science. This is applicable to metaphysics. This is a metaphysical statement. If you remember, metaphysics studies being as being. All the other investigations or disciplines of humans study being as something, being as living things in biology or something else, physical things related to it. But this is the study of being as being, and so this has a application to metaphysics. But nonetheless, some purport or put forth the notion that science has shown this to be wrong, and this is applied especially at the quantum physics level, where they say that on a subatomic level, events are simply uncaused. Well, this is just not the case at all. the Copenhagen interpretation and is the deterministic interpretation. Um, Many modern physicists are not convinced of this interpretation, but it's also important to understand that even in this interpretation, the Copenhagen interpretation, it is not out of nothing that is being put forth in a metaphysical sense, but it's arise as a spontaneous fluctuation of the energy contained in the subatomic vacuum. This principle at the quantum physics level or this objection at that level, is really dealing with not nothing, but vacuums. And vacuums aren't nothing, since, in fact, this is often put forth in popular magazines to the notion that something came from nothing. But you have to understand that a vacuum in science is not nothing. It's not non-being. A vacuum itself is defined as a sea of fluctuating energy endowed with a rich structure and subject to physical laws, which certainly can be subject to measurement. So you're not dealing with nothing at this level. Again, I think this objection confuses metaphysics with science, and that's really the fundamental answer to this objection. Now, Alexander Vilenkin has put forth this notion of a quantum creation model where he reduces the universe to a tunnel with zero radius rather than a point, and he even in his illustration has this notion of it. So instead of, as we'll see, the standard model, which puts the beginning of the universe in terms of a point of infinite density, his model rounds it out in terms of a tunnel. This being the case, there's really no point to it, since there's no one point to indicate the beginning of the tunnel, and this gives it a radius of 0. But again, I don't think that this is an objection or a valid objection to our metaphysical principle, because it's important to understand that having a 0 radius is not the same as having no radius at all, or non-being. Again, even 0 is something that is measurable in scientific terms. Hence, it's not dealing with metaphysics, it's dealing with science. Also, we would put forward the notion that it's absurd to put forward the understanding that something small coming into existence out of nothing is more believable than something big coming into existence out of nothing. I don't think that this holds against this principle, that everything that begins to exist has a cause, mainly for the fact that they're trying to come up with scientific examples that counter this metaphysical notion, and that's just never the case. Because metaphysics and science are different areas of discipline. So that leads us to the second premise in defending it. The universe began to exist. Now this we'll spend quite a bit of time on. First we'll actually defend it this way, and then we'll answer some objections to it. Our defense will consist of a philosophical argument. We'll give two philosophical arguments, one on the impossibility of an actual infinite, and the second one on the impossibility of forming an actual infinite by adding things. The second area that we'll deal with is two scientific, or what we might refer to as empirical arguments, one dealing with the expansion of the universe, and the second one dealing with the thermodynamic properties of the universe. So again, we'll give two philosophical arguments in support of the second premise, and we'll give two scientific or empirical arguments in favor of the second premise. First off is this notion of the impossibility of an actual infinite. Let me outline Dr. Craig's philosophical argument in support of this, the first philosophical argument. He says an actual infinite number of things cannot exist. A beginningless series of events in time entails an actual infinite number of things. Therefore, a beginningless series of events in time cannot exist. Now, we have to distinguish two things here. The first one is what an actual infinite as opposed to a potential infinite. Now, an actual infinite is a collection of members whose number is greater than any natural number. That is, any of the natural numbers, 0, 1, 2, 3, and so forth. If it is greater than that, it is considered to be an actual infinite. This is symbolized in math by the Hebrew aleph character with the subscript of 0 being indefinite or being infinite. Now, there's also a potential infinite. This is the notion that something increases toward infinity as a limit, but it never arrives at it. And this is the very common symbol that's used for this in mathematics. Now, it's also important to point out this notion of you can certainly have cognitive or mathematical infinites, as we can show here. But what we're going to object against is the notion that these can actually be applied to reality itself. And when doing so, some absurdities result in the process or in the act of trying to apply an actual infinite to reality itself. Now, it's important also to understand that the first premise of an argument asserts an actual infinite, not a potential infinite. This is not counting upwards to infinity as a limit, but it's saying an actual infinite cannot exist. An actual infinite may be a good concept. It may be something that is applicable in the arena of mathematics or in the arena of mind and cognitive things. But when it's applied to the real world, it results in what we would refer to as counterintuitive absurdities. Our first premise, an actual infinite number of things cannot exist, asserts an actual infinite. Again, not a potential infinite, but an actual infinite cannot exist. And the second premise, a beginningless series of events in time entails an actual infinite number of things. If the universe did not begin to exist, then there must be an actual number of previous events. Time would entail an actual infinite number of things. We'll look at two examples that show the absurdity of this. That is, an infinite library of books results in certain absurdities when we apply an actual infinite to real things. And then also we'll look at Hilbert's hotel with respect to this particular issue and see that really, if it's the case that we're going to apply an actual infinite to the real world, then we really would be living in a world that would be akin to Alice in Wonderland. If in fact an actual infinite does apply to our world. And if we can't apply these to the real world because of these absurdities, then the past, that is time and events, must be finite or they must have a beginning. And therefore our conclusion results, therefore a beginningless series of events in time cannot exist. So let's take a look at these applications or examples of application with regards to an actual infinite to reality itself. If you can imagine an infinite number of real books, and you can start off saying with this notion of, let's say they're each different colors. So there's red books and there's black books. One absurdity that we would have immediately is this notion of the number of black books to red books. Would be the same. You would have an infinite number of red books and an infinite number of black books if you could somehow differentiate them. As absurd as that might be, it gets even worse. Would we believe that someone who told us that the number of red books, since the library is the same as the number of red books, plus the number of black books, that this is ultimately what we mean in terms of an infinite number of real books again. That is, that the black books plus the number of red books are an infinite set as well. All the books in the collection are no more than the number of books that there are of any single color. But this just doesn't seem possible ultimately. In fact, we could again illustrate it this way. Let's say that every possible natural number is printed on the books. This would make it impossible to add another book to the library because every possible natural number is printed on the books. What would be the next number? But if all the numbers are used up, you wouldn't have a next number because again, there are an infinite number of them. Entities that exist in the world can be numbered. That being the case, you can't use up all the numbers, but it seems like you would use up all the numbers if they're actual infinite number of entities in the world. If that's the case, then the collection is not infinite. These illustrations show that if an actual infinite could exist in reality, it would be impossible to add to it. But obviously, it is possible to add to, say, a collection of books. Just take one page from each of the first 100 books, add a title page, and put it on the shelf. Therefore, an actual infinite cannot exist in the real world. This is the type of absurdity we get with respect to applying an actual infinite conceptually to the real world. You could also illustrate it this way to say, let's take out some of the books, a set number of the books, whatever it is, take out 1,000,000 of them. You still have an infinite number of books in the library. If they're real books, you didn't detract from an infinite or take any of the books away, actually, because you still have an infinite left. Yet you can conceivably take out 1,000,000 books from the library. But again, the absurdity would show you that you just can't have an infinite number, an actual infinite, be applied to reality itself. Another good way to illustrate this is Hilbert's hotel. This was from David Hilbert, where he said this notion of imagine a hotel. First, let's imagine a hotel with a finite number, all filled with new guests, and we would say that the hotel is filled if it has a finite number, and there's no room for occupancy whatsoever. But now let's say or imagine that the number of rooms in the hotel are infinite, and let's say that the rooms are all filled up. But let's say that a new guest arrives. Is there room for the new guest? Well, if he moves all the guests to the next room to open up room number 1, then he can accommodate for that guest into the hotel. Would seem to be indeed possible. All he has to do is is to move all of the guests from one room to the next room, 1 to 2, 2 to 3, and so forth. Room 1 is open and he can accommodate the new guests that arrive. But let's say we have an infinite number of guests that arrive. If that's the case, then he could conceivably move all the odd number rooms to the even number rooms and accommodate an infinity with respect to the number of new guests they're actually accommodated for. Because again, if you remember with regards to an infinite, you can take two infinite sets corresponding to another, and they would correspond directly to one another. So you could indeed have the number of guests be accommodated if it's an infinite number of guests. But of course, this works only if it is a potential infinite. That is, if it counts on forever and ever, not an actual infinite. In other words, it works in reality towards the future if you only deal with a potential infinite. But that's not what we're asserting or trying to negate here. In fact, what Dr. Craig says about this is we are trying to take a conceptual operation guaranteed by the conventions of the principle of correspondence, that is correspondence to reality, and apply them to the real world of things, and the results are just not believable. Again, these are things you can do conceptually in your mind, but when we try to take them in terms of an actual infinite and apply it to reality, either in terms of an infinite number of books or in terms of Hilbert's infinite hotel, these absurdities just result, and it just does not work, and there's no way, and many mathematicians have recognized that there's just no way actual infinites can apply to the real world. Now the next argument we have for the impossibility of an actual infinite existing in reality goes like this. The series of events in time is a collection formed by adding one member after another. A collection formed by adding one member after another cannot be actually infinite. Therefore, the series of events in time cannot be actually infinite. Now, this is not the same as the foregoing argument, since this does not say anything about there already existing an actual infinite. It simply is saying that you cannot make up an actual infinite by adding one member after another member after another member ad infinitum. And that cannot produce, in reality at least, an actual infinite. In other words, the past did not spring into existence fully formed. Given the past, the present, and the future, are real or objective, few should disagree with premise 1 here. The series of events in time is a collection formed by adding one member after another member. It's also important to point out that time is really irrelevant to this particular argument. One can neither count to infinity nor count down from infinity. In fact, if we could imagine someone who comes to us, let's say we find a man who counts down from infinity and he says, I am now done. He goes -3, -2, -1, 0. We would ask the question, well, why didn't he finish? Why did he finish now or today and not yesterday? An infinite of time or an infinite of time being given, he should have already been done. He should never have finished on today. In fact, we would never find him counting at all, since he would be done at any point, since it is, again, from infinity that he's counting down. But this counters the claim that he has been counting down from infinity. So again, we end up with these notions of absurdity, that you just cannot have an infinity or an infinite in terms of adding successively one after another in the time-space universe. It just results in counterintuitive things, such as the man who would count to infinity or count down from infinity. You can also see the notion of this impossibility with regards to the notion of traversing an infinite. Hence, if time is infinite, we could never have arrived at today. Today could never have been or could never be today if in fact time is infinite or goes on forever and ever. That is, there's no beginning to it. But if the series of past events is beginningless, we could never traverse it, or we could never have arrived at the present today, which is absurd because you'd have to say that the present of what's going on right now is just an illusion or not real. That being the case, again, putting infinity or an infinite into time just results in these absurdities, at least in terms of adding succession or adding one member after another member. That being the case, this seems to be a good argument against an actual infinite as well, either through successive membership and the previous argument we gave with regards to applying an already existing actual infinite to reality. So these are two good philosophical arguments. Now let me answer some of the objections, and they've used Zeno's paradox for this objection. Now, if you remember Zeno's paradox, it has to do with the fact that Achilles will never catch the tortoise because he must, the tortoise is given a head start in terms of a race, and Achilles will never catch the tortoise, even though he's much faster, because even as the tortoise moves from time 0 to time 1 to time 2, Achilles can ultimately never get started, because in order for him to get started, he must traverse half the distance to catch up to the tortoise, but he can't even do that. He'll never do half the distance, because in order to do half the distance to the tortoise, he has to do half of that distance. In order to do half of that distance, he has to do half of another distance, and so forth. So actually it ends up that Achilles never actually moves at all. Now the thing to point out about this is I don't think that this really is a good objection to premise number 2, that a collection formed by adding one member after another member can be an actual infinite. Because what's really going on here, whatever else is going on in Zeno's paradox, is really a thought experiment. It deals with potential intervals while we're dealing with the possibility of an infinite past. This would entail actual infinite intervals. Zeno is infinite intervals with regards to a sum that is applied to a finite distance, while the intervals that we're dealing with are an infinite past that sums to an infinite distance. So that being the case, for this particular instance, I don't think it's analogous at all. It's actually disanalogous. The actual infinite must be all at once or not at all with regards to this application. So again, I think Zeno's infinite intervals summing to a finite distance, while our intervals are an infinite past that sums to an infinite distance. So again, I don't think that there's a clear analogous relationship between the two, such that this would serve as a objection to premise number 2. Now, the second objection that is raised is the notion that this presupposes an infinite distance starting point. Then say it's impossible to travel to today. But every given point in the past, it would seem, is a finite distance to the present. Well, I don't think that this particular objection is really relevant to the overall Kalam cosmological type argument. There's no defender of the Kalam argument that is claiming an infinite distance starting point, an infinite distance starting point to the universe. How is claiming that from any moment in the past there is a finite distance to the present relevant? The issue is the whole series, not just a finite point or portion of the series. Dr. Craig uses the example of saying that can every finite segment of a series make the whole series infinite? Not possible. That's like saying that every part of an elephant is light, therefore the entire elephant is light. You can't just add up finite segments of the series and make the assertion that therefore the whole thing is infinite because of all the finite segments. Not possible at all. If the series of past events is beginningless, then we could never have arrived at the present. So with our first overall premise, or with the first overall argument being given philosophically, we now want to move or transition to our two empirical arguments for the beginning of the universe. Many might find the philosophy hard to understand, and maybe even some of the mathematics hard to understand. And here it may be a little bit more straightforward for some people, having a better grasp of some of the science that's involved. First of all, I want to put forward this notion of the standard model that exists. Before the standard model came into existence, and we'll discuss how that came about in just a little bit, but before this standard model existed, there was the view that the entire universe was static and timeless entity. In fact, if you would go back to the time of Immanuel Kant, the predominant view of philosophers as well as the predominant view of scientists was this static, timeless entity with regards to the universe, having no beginning and no end to it whatsoever. But some amazing discoveries with regard to the turn of the century came about. First starting with Albert Einstein in 1917, where he developed his general theory of relativity. His general theory of relativity would not permit an eternal static model of the universe, unless, of course, he fudged the numbers, which he did at first, in terms of his equations in order to offset the gravitational effect of matter. Matter under his model would cause the universe to implode or expand, clearly indicating that it had a beginning. But this was something that he was not interested in pursuing, and it disturbed him quite a bit. But then some, in terms of general relativity, took his theory of general relativity and applied the correct mathematical models to it. Friedman did this using Einstein's equations combined with general relativity, and the theory did not depict the expansion of matter into pre-existing matter, but actually the expansion of space itself was put into the notion of this. So Friedman's mathematical model was really the first to be put forth in terms of mathematics with regards to an expanding universe. And again, this expansion is not into space, but it's the expansion of space itself. Now, it was Fred Hoyle that gave it the popular term or the popular name Big Bang theory, which it is popularly known as. But this is somewhat of a misstatement, or it's a little bit misleading with regards to this. The expansion in terms of a Big Bang is really not the correct visualization of it. It's not an expansion of the universe into already existing space, which is what the concept we have of something that's a Big Bang. Really, it's the expansion of space itself, which is hard to imagine. You can only think of it in terms of actually being inside of the implosion, since it's going on from the inside, not being outside watching it. It was Edwin Hubble that provided the empirical observations in astronomy with regards to the Big Bang Theory or the Standard Model and applied it ultimately to uh, or applied the empirical observation that was needed to back up the mathematical models that were being formulated to explain this. All matter and energy, space and time, uh, came into existence through an initial cosmological singularity. If you take this notion of what Hubble has observed, which is referred to as the Doppler redshift, he discovered that the galaxies are moving away from each other and also away from a common center. Uh, this was noticed in the Doppler redshift. This is very similar to what you would experience if you were standing out in front of a street and heard a siren off in the distance, and the siren got closer and closer and got louder until it was right in front of you, and then it receded against you, or as the siren goes away from the fire truck or the ambulance, it gets lesser and lesser. This is what he observed in terms of light emitted from galaxies. A blue shift in the light would show that the galaxy is actually moving towards us, but what he was able to observe was a red shift, which clearly showed it was moving away from a common center. This being the case, again, all matter and energy, space, and time came into being in an initial cosmological singularity. Now, this was put forth in terms of what was referred to scientifically as a point of infinite density. But this is what philosophers would come along and say is the same thing as nothing. If you have infinite density, you have nothing at all. Now, the mathematics for this were able to be applied to it in a theoretical sense and to explain everything physically in terms of taking us back to what is referred to as Planck time, which is 10 to the minus 34 seconds with regards to the implosion of the Standard Model. That being the case, it doesn't take us back right to the beginning point or the infinite density itself. It's here where our physics and our mathematics really start to break down. We really have no existing physics to take us back before Planck time. We can go back to Planck time, explain what we need to explain, but to go any further than that, to take us back to the initial cosmological singularity itself, we don't have the mathematics or the physics to actually explain it in terms of that. That being the case, there have been a number of alternative theories that have been put forth. And we'll take a look at each of these briefly, but it's important to understand, and I think Dr. Craig makes some valid points here. First, we have to understand the nature of science with respect to this issue, and also given this Planck time mystery that exists, and the natural science. Natural science works on hypotheses, and given the mystery of Planck time, there are probably always going to be alternatives that are suggested to the Standard Model. That's really the way science works. If there weren't any alternatives being put forth to it, science wouldn't be doing what it's supposed to be doing. Given the mystery of Planck time, there are going to be, and probably always be, unless the Planck time is solved, there are always going to be alternatives that are put forth with regards to this particular issue. And we should welcome that, at least as scientists. We should welcome alternative theories. But it's also important, as we'll see, that none of the alternative theories has received the wide circulation and acceptance of the Standard Model that we have put forth here, which is popularly, again, known as the Big Bang theory itself. But just briefly, we'll look at the steady state model, the oscillating model, vacuum fluctuation models, chaotic inflationary models, quantum gravity models, and even most recently, string scenarios relevant to M theory or string theory. The first one is the steady state model. In response to the Standard Model in 1948, it was put forth that the universe is in a state of cosmic expansion. It acknowledged the expansion of the Standard Model. The universe is the same in every direction in terms of its expansion, but it postulates that new matter is coming into existence ex nihilo, or out of nothing, in order to fill the voids left between the galaxies, such that the density of the universe never really increases. Uh, the major problem with this particular view is that there's actually no empirical evidential support whatsoever for it. It's easy to say that matter is coming into existence ex nihilo, but there's no evidential support for that whatsoever. And two discoveries that further supported the standard model around the same time that this came out really nailed the coffin shut on this particular view. First of all, the primordial nucleosynthesis of stars could not manufacture light elements such as helium and deuterium. These must have been created at the first moments of the Big Bang or the implosion because it could not be done after the initial moments. That being the case, and since these were in quite of abundant present in the universe, this must have been done very early on, which shows that the steady state model could not have been or could not explain this phenomenon. Second, in 1965, radiation was discovered in the microwave regions of the spectrum. That being the case, this was actually emitted during the early hot dense phase of the universe, and it was predicted that this would be there by the Big Bang Theory, and it was actually discovered again in 1965, and this has actually been reaffirmed by many other discoveries as well. This is very similar to firing a gun in the room and then having the person that fired the gun run out of the room. You would predict as you would walk into the room that there would be, you might even, if you walked in right after the gun was fired, you would see smoke from the gun, and you would even smell the smell of the gun. You would expect evidence to be there of it. Well, this is the exact same thing that was predicted with regards to the Big Bang implosion. We would expect to find this type of radiation, and we did find it in terms of the microwave region of the spectrum. So this again gave more evidence to the standard model and eventually put to rest the steady state model, which is not looked as a viable option at all. The second one is the oscillating model. This was put forth in the 1960s, and it denied the standard model because it hypothesized that there are internal gravitational pulls that could be overcome and reverse the expansion into the cosmic and cause a cosmic contraction. So you have this big crunch that takes place after the Big Bang. So you have a Big Bang, and then you have a big crunch where everything collapses upon itself. But the collapse would not be a single point, it hypothesized, that since matter is not evenly distributed in the universe, matter would pass by each other and appear to expand again. If this was indefinite, then it would seem that there would be no need for an absolute beginning. You would have these Big Bang explosions, and then you would have these big crunches that would take place, and then more implosions would take place. But the further research on this, Hawking and Penrose put forth their notion of a singularity theorems, showed that the initial cosmological singularity is ultimately inevitable. Even in terms of a generalized uneven universe, it is definitely inevitable. First of all, there's no known physics that can explain an oscillating universe. We don't have physics in place to establish the notion of this big crunch that would take place after the Big Bang. Second, the observational establishment of the mass density to cause a halt to the reverse failed to appear. Measurements were taken as early as as recent as 1998, and there's no observable mass density that would cause a halt to the expansion. So there's no empirical backing of this. And also the redshift in supernovas actually has revealed some unexpected results with regards to supernovas, and that the expansion of them has actually increased or accelerated. This is being put forth with regards to the notion of dark energy existing, which is a variable energy that is needed to give it a cosmic kick. But the fact that you have this acceleration taking place in some parts of the universe, again, just deals a death blow to the oscillating model, which is calling for everything halting eventually and coming back together. The physics isn't there, and the empirical evidence just isn't there to say that that's going to happen. The vacuum fluctuation model, this was put forth in 1973 by Edwin Tryon, and he speculated that the universe prior to Planck time, this would put it into 10 to the minus 35 or 10 to the minus 33, might be a long-lived virtual particle emerging from a vacuum. So this is kind of taking what we've seen in terms of subatomic particles and how they behave in a vacuum and saying that our entire universe is just having the behavior of a subatomic particle and exists in a vacuum-like atmosphere. Here the universe was not expanding. Here matter is created in or what we would call mini universes are born in this vacuum. Over time, they come to exist, and then they ultimately cease to exist kind of erratically. Hence, the universe is just one of many mini universes in an uncaused universe as a whole. So here it says that the mini verses are all caused, but the whole system itself that it exists in, this vacuum, is kind of uncaused. Well, the problems with this are quite numerous. First of all, it's given an infinite past time, such as a miniverse, should have spawned at every point in the vacuum these miniverses, such that they should have completely filled vacuum if this vacuum exists for infinity. Our universe should be infinitely old also, not relatively young as put forth by some of the measurements made in support of the standard model. Further, they should have all coalesced. The only way to avoid this problem is to postulate an expansion of the vacuum itself that has all the miniverses in it. But that takes us back to the standard model, if that's the case, and there's just again showing that the entire vacuum itself needs the cause, not just the miniverses themselves in terms of the cause. Next, we have the chaotic inflationary model. This is Andre Lin's model, and it says that the inflation never ends. Once it reaches a certain volume, it gives rise to another domain, such that you can have these chaotic inflationary models taking place all over the place. Such a model asserts an endless future, but it also says that the past can be beginningless. That is, there's no need to assert a beginning to the past. It just doesn't need one in order to have these chaotic inflationary model supported. But in 1994 and 2003, Board and Vilenkin did additional work that showed that any inflation towards the future demands a past singularity. So it really ultimately doesn't matter with regards to the chaotic inflationary model. Any type of inflation that exists, whether it's multiple or not, is going to demand a past singularity, at least according to the work that's been done as recent as 1994 and 2003. So this really hasn't solved the problem. Then there's the quantum gravity model. This one put forth by Board and Vilenkin as well, and we mentioned this earlier, where they simply round off the Planck time itself using a wave function rather than a classic space-time model. This is done using imaginary numbers being applied to Einstein's gravitational equations, which eliminates the need for a singularity. It postulates a closed surface prior to Planck time, which would seem to model a universe without the need for a singular starting point. Now, there are a number of problems with this. First of all, it makes time indistinguishable from space. But time, we would see, is metaphysically distinct from space, since moments being ordered by earlier than relations would seem to be the best understanding that corresponds to our experience. But this understanding completely obscures this whole process, or this whole distinction, by the use of imaginary numbers. The second thing is that all that have looked at this particular model, including Stephen Hawking, who has praised this model as well, clearly admit that their math has no application to reality itself. In other words, using imaginary numbers, the math just does not apply to reality. It constructs um, an unrealistic understanding of the universe itself with no applicability to reality. It's not ultimately applicable because of the math that's involved with this to the space-time universe. And it does not, therefore, explain all the observational data and math that is applicable to the universe. It just kind of goes around it using imaginary numbers and math. So that being the case, this has fallen to the wayside as well. And the last one is the newest one, which put forth the notion of string scenarios, or sometimes this is referred to as M theory. M theory or string theory says that the fundamental building blocks of matter are not subatomic particles such as quarks, but tiny vibrating one-dimensional strings of energy. Now, admittedly, this has solved a number of mathematical issues and problems with regards to understanding the universe and has tremendous mathematical explanatory power, but not all the math has worked out on this as well. And prior to the observational expansion, there is an unobservable, this view says that prior to the observational expansion, there is an unobservable contraction phase that forms various black holes. So you can see in the diagram you have the observable universe, which gives us the particular V-shape expansion of the universe. But then you have this expanding region and a contraction region that is just not observable to us, but again, mathematically, we can explain it through string theory. This allows for a contraction to go on as long as the expansion goes on. So as one goes on, the other goes on. So as long as we have expansion going on, we also have in the unseen world this contraction going on. If one is forever, that is, the expansion goes on forever and ever, then the other one is forever, that is, the contraction going on. Hence, a beginning would seem to have been completely avoided with respect to our universe. Our universe is just one collapsing, rebounding in a wider universe. The problem with this is that if we postulate an infinite time, then all pre-Big Bang black holes should have coalesced into a massive black hole coextensive with our universe. Also, and that of course hasn't happened, and also we have the issue of the thermodynamic equilibrium in the universe. We'll talk about that in just a little bit, but this notion of thermodynamic equilibrium would put an end to this because we don't have that completely existing yet in the universe. Much string theory, while having a lot of mathematical explaining power, is still very speculative and really does not remove the need for an initial singularity. That being the case, this one has not superseded the standard model as well either. Now, as I mentioned before, it might indeed be the case that as long as we have a Planck time mystery, we're going to have alternative theories. But something very interesting happened in 2003. And Dr. Craig mentions this in this quote. He says, theorists intent on avoiding the absolute beginning of the universe could previously always take refuge in the period prior to Planck time, an era so poorly understood that one commentator has compared it with the regions of maps of ancient cartographers marked "Here There Be Dragons." The Guth-Vilenkin theorem does not depend upon any particular physical description of the universe prior to the Planck time, being based instead on deceptively simple physical reasoning, which will hold regardless of our uncertainty concerning that era. It single-handedly sweeps away the most important attempts to avoid the absolute beginning of the universe. This work that's done by Board, Guth, and Vilenkin seems to really have nailed the coffin shut with regards to any theory that is going to be put forth that denies a singular beginning to the universe. There still may be alternative theories that are put forth, but the standard model really is strengthened quite a bit, at least since 2003, or at least we should put it this way. The alternative theories have really had the door closed on them with respect to this being put forth in this work that has been done here. That being the case, again, I think there's good empirical evidence for the standard model, or at least the standard model as a scientific hypothesis has the greatest explanatory power with regards to all the known mathematical data applied to reality and all of the empirical observations that have been made with respect to the universe. Now, the second reason, empirical reason, to be given for the beginning of the universe is this notion of the second law of thermodynamics. Now, if you remember, the second law of thermodynamics says that heat only flows from a point of high temperature to a point of low temperature. Now, this can be applied generally to all forms of energy, such as gas, electricity, and so forth. Let me give you a few examples of this. What this law is stating is that if we were, for example, to put hot boiling water on one side of a bathtub, divide it from freezing cold water on the other side of the bathtub, it's going to say that when I lift up the divider, the hot boiling water is going to flow in with the cold water, and you're going to eventually have lukewarm water. What this says is that happens on average, is that things mix, and you never see the reverse taking place. You never see, left to itself, hot boiling water to divide and exist on one side of the bathtub and cold water to exist on the other side of the bathtub. That just doesn't happen in reality without, of course, intervention into the system itself. That being the case, this makes life possible. We can walk into a room and we don't have all the oxygen separating from its other gases on one side of the room and the nitrogen separating from the oxygen on the other side of the room. If that was in fact happening, then we wouldn't have the possibility of life. So the second law of thermodynamics applies everywhere that we have energy in the universe. This is also described by the notion of entropy. It says that things flow from a state of order to disorder, or what is referred to as low entropy to higher entropy. This is the math that is described, that is used to describe this notion of disorder. So all systems go from a low entropy to a greater or higher entropy. That is, processes in a closed system ultimately tend toward equilibrium. That is, they run down and they ultimately quit. Now, this applied to the universe has given us two end-time type scenarios. One is a big crunch, which we kind of mentioned a little bit ago. It says that the density of the universe may reach a critical value in which the gravity will eventually cause it to collapse back on itself. That is, all the black holes will coalesce into one large black hole. The problem is that we haven't found that critical value, and we really don't have any physics that would describe a bounce back to this entire system. So this isn't as predominant as the second theory or end time scenario. The second one has to do with the fact that the density of the universe reaches a critical value. Gravity will not be overcome by the forces of the expansion, and the universe will progressively slow on an indefinite basis. That is, that all black holes evaporate, and every aspect of the expanding universe is reduced to a very thin gas or elementary particle or radiation. That being the case, you reach the state of equilibrium, you're dealing with what is referred to as a heat death. That is, we end up with equilibrium, that is a cold, dark, dilute, and dead universe. This is known as thermodynamic extinction. Now, for all intents and purposes, the notion of thermodynamics as applied to the universe as a whole or to any part of it is really a closed science. No one is questioning that this law applies to the universe itself. That being the case, anybody that puts forth the notion that the universe has always existed, this flies right in the face of it. If the universe has always existed, how come we're not at equilibrium right now? How come we're not at a heat death right now? If we were at a heat death right now, we wouldn't be saying anything because we would all be dead, according to this principle. Also, philosophically, the universe cannot be an actual infinite. And empirically, there's no evidence that the universe must be infinite, as we've already looked at in terms of our argument that we've already given with respect to the philosophy behind it. So that being the case, and this being a closed issue in science, This point, this notion of thermodynamic properties of the universe is actually stronger than the previous point that I gave with regards to the standard model not having a good or viable alternative. This one is really to be understood as a closed science. No one is actively putting forth any notion that there's an alternative to this thermodynamic second law of thermodynamics. There isn't. It's a law of science. It's as firm as you can get in science. So that being the case, it's a clear indication that the universe must have began to exist on empirical grounds. So therefore, the universe has a cause. Now this seems to follow directly from our argument itself. If premise 1 is correct and premise 2 is correct, then the conclusion follows. The universe was brought into existence by something that is greater than it and something that is beyond it. Now, some would object that the universe is itself the cause of its existence. In fact, Daniel Dennett, in his book Breaking the Spell, objects to this conclusion by saying the universe is itself the cause of its existence. But this is just metaphysically absurd. You've heard enough in terms of the arguments for the existence of God and the vertical in this one to say that self-causation, or causa sui, as we would put it in the Latin, is just metaphysically absurd. So what is the nature of the first cause? It's here that we start the process of taking what we've concluded from our Kalam cosmological argument and apply it to showing that this cause must have certain attributes or qualities that are attributed to it. And also, these attributes or qualities that we would attribute to it are the same attributes that are spoken of the God of the Christian scriptures. Hence, we can match the two together. So what is the nature of the first cause? What can we conclude based on this Kalam cosmological argument? What can we conclude about the first cause? Well, first, we would say that the cause of the space-time universe must transcend the space-time universe. That is, it must be atemporal, that is, outside of time, and non-spatial. It's not bound by the space-time universe. That being the case, we would say that it's timelessness. It does not entail time before and after. That would seem to imply or entail that it's changeless, that this being does not change in any way. Its changelessness would also imply that it's immaterial. That is, it's not made up of matter itself, which is bound to the space-time universe, which implies this notion of changing. So it's beginningless and it's uncaused also, since an infinite regress is ultimately impossible. And here you could actually take an argument from the vertical cosmological argument that an infinite regress is impossible, and you could apply it right here with respect to the notion or nature of a first cause. We would also say that the first cause has to have unimaginable power. We can certainly speak in terms of understanding the universe in terms of its power and energy and quantifying it mathematically. But here, this must be way beyond anything that can be quantifiable, since it's outside the space-time universe and outside the energy of the space-time universe. After all, it brought all of the space-time energy of the universe into existence itself. This notion of the creator or the cause, the creation, is without material cause. So no matter was used, no pre-existing matter or matter at all was used in terms, or materials were used in terms of creation itself. So the power is beyond, or it must be literally referred to as supernatural power, or power that is ultimately unlimited in any sense of the term. We could also say and put forward the notion that the cause must be personal. Now this may not be evident, but I think a little reflection on this will show that this must be the case. At least it's not immediately evident, but if we think about it intuitively, I think we'll see that it must be personal. There are basically two types of causations that are applicable here. One is a scientific causation. This would explain the initial conditions or laws that exist. The other types of causation would be a personal cause. And let me give you an example. If you walk into the kitchen, and I'm in the kitchen, and there's boiling water that's on the stove, and you ask me what is the cause of the water boiling? And I give you the answer that kinetic energy is moving the water molecules, which breaks the surface temperature and throws the water off in terms of in a form of steam. That's a scientific causal explanation with regards to heat heating the water, causing the molecules to burn or to move very rapidly, and ultimately being given off, breaking the surface of the water, and the molecules being given off in the form of steam. That's just a scientific answer. The other answer that I could give you is I'm boiling water because I'm going to boil and make a hard-cooked egg. And you go, oh, okay, and walk out of the room. That's probably the answer that you were looking for. But the second answer that I gave you is really a personal answer. It's a personal causal answer. The universe has no scientific cause, scientific explanation for why it exists, why it came into existence. Science can't answer that for us. It's never going to answer the why question with regards to the universe. That being the case, the only other type of causal explanation is a personal answer. That is, someone has intent, volitional intent with regards to the cause of the universe. It exists because they volitionally willed it into existence. That being the case, that takes a personal choice or a volitional choice on the part of the cause. So therefore, the cause must be personal because, again, there's no scientific explanation whatsoever for the cause of the universe in terms of why it is rather than it not being. So it would seem upon that type of reasoning with regards to causation that postulating a personal cause of the universe is a reasonable explanation for its existence. That is, another way to argue for this is to think of it in terms of what we might say entities that are outside of time. What are the kinds of entities that can be outside of time, that is the space-time universe? Well, philosophically speaking, there are only two that meet it. One are minds without bodies in terms of a mind existing, and the other are abstract objects. That being the case, abstract objects, though, cannot put forth the notion of choice or choosing. Some would put forward the notion that abstract objects would be such things as numbers existing, eternally speaking, outside of time. I'm not here to debate whether or not that's the case, but that's the point as to whether they could be the cause of the universe. But those don't have choices involved. So the only other option is this notion of mind existing. And of course, if you put forward the notion of mind existing, then you're dealing with persons, because only persons have minds. Abstract objects don't. So therefore, mind caused the universe to come into existence. Well, that being the case, there are a number of things that we've concluded about the first cause, such as it being timelessness, it being immutable or changeless. There's no beginning. It's uncaused. It has unimaginable power, or we might speak of infinite and eternal with regards to its power and its ability, and also the fact that it must be personal. This being the case, we turn to the scriptures itself. We find the very same being depicted in the scriptures. God is depicted as being eternal, that is outside of time since he created time. He's immaterial since he's spiritual. Since matter is finite and changing and it can't be eternal or outside of time. He's immutable or unchanging, that is, he does not change since only finite changing things or finite beings can change. He's omnipotent since he created it from nothing. There's no material causation of the universe or no material cause out of which it came. It came from nothing, which would imply the notion of being all-powerful. Omnipresent since he's immaterial and the creator of space and time. He cannot be limited by space and time, so he can be present everywhere. He's omniscient since being itself is unlimited, being outside of space and time in terms of his intelligence. And he's personal, as we've indicated, in terms of the Kalam cosmological argument is an inference that can be made since the cause had to be willful or intentional with regards to the universe. He's also personal, and there can only be one. As we've seen from the vertical cosmological argument, there can only be one. There cannot be two infinites. To have two infinites doesn't make any sense because you'd have to tell them apart, and to tell them apart, one would have to lack what the other has. That being the case, it wouldn't be infinite if it lacked anything. So there can only be one such being. This is the description, the metaphysical description of God in terms of Scripture. That being the case, it would seem to be a good match or a good fit with the cause that is concluded from the Kalam cosmological argument. So we can put the entire argument together with regards to the Kalam cosmological argument, and it can also extend the argument out further to match it with the God of Christianity or Christian theism. Everything that begins to exist has a cause of its existence. This is verified by all the known empirical data with respect to the universe. The universe began to exist. This is proven through philosophical reasoning about the beginning of the universe, that being an actual infinite is impossible in terms of it existing all at once, or in terms of it existing by adding successive members to it. And also the empirical data. We argued that the standard model is that the universe began to exist a finite time ago and has been expanding ever since, and that there's no real serious challenge, empirically speaking, to this hypothesis or this theory, and it explains the empirical data better than any other. Also, with regards to thermodynamic properties, the second law of thermodynamics as well, which seems to indicate that since the universe has not completely run down or reached equilibrium, which it is in the process of doing, we again do not have heat death. Therefore, the universe is still must have a finite past with respect to its starting point. Therefore, the universe has a cause of its existence. This follows categorically from the first two premises, 1 and 2. We can also add to that this cause is the Christian God. This is made from matching the necessary attributes or the conclusions that we've made from the cause based on our argument and matching it with the Christian theistic God. And seeing that the attributes are the same, therefore the God must be the same because you can't have two infinite causes. Now there are a number of objections that have been put forth to the Kalam cosmological argument. I don't think that they're substantial objections, as we'll see as we go through each one, but nonetheless they are objections that have been put forth, so we do need to answer them. The first objection we'll look at is Kant's first antinomy, shows that such cosmological arguments are impossible. If you remember from Immanuel Kant, he put forth a series of antinomies, that is, conditions which are put forth in terms of thesis and antithesis. He puts forth a thesis one way, and then the antithesis seems to be just as legitimate, and therefore it cancels itself out. He does put forth one antinomy that does have to do with this particular argument, or at least at first seems to have implications for this type of argumentation. First of all, he says that the world must have a beginning in time, or there is an infinite number of moments have elapsed, which seems to be impossible. That is, the infinite is not completed yet. The antithesis says that the world cannot begin in time, since there would be time before time began, which is ultimately a contradiction. But I think this is easily answered by understanding accurately our argument. We gave an argument that states that the space-time itself began with the universe. There was no time before the universe. So if you can understand the argument in terms of establishing the time-space continuum itself, then we don't have to worry about time before time beginning or any problem with respect to that. So I don't think his antinomy or his thesis or his antithesis really is an objection here, because we've actually carved out a third ground, that is the beginning of the space-time universe itself. The second objection comes from Adolf Gronholm, who says that the argument equivocates on the term cause. He says that when we use the term everything has a cause, which remember we didn't actually use that term that everything has a cause, or that phrase that has a cause, but he says we did. We've answered that objection already. But he says we equivocate on the term cause because we use it in terms of something that is material coming from one state to another, and we use it with respect to something coming into existence from nothing. And therefore, our argument, he says, equivocates on the term cause, therefore it's invalid. But I don't think that's the case at all. The cause that we use here is univocal. That is, we actually do not equivocate on it. We use the term univocally, which means to bring about or produce its effect. The means of the causation, whether it's in terms of a material cause or in terms of a cause from nothing, is really incidental to the argument itself. Those are two different types of causation, no doubt. But as long as we understand that the univocal meaning of the term cause in the argument itself is to bring about or produce its effect, then we are not committing a fallacy of equivocation. Grumman's argument also is put forth, or an objection is put forth by Adolf, in terms of the personhood or the conscious agent that we argued following from the argument itself. He says that this doesn't follow from the argument. There's no personhood that follows from the argument proper with regards to the Kalam cosmological argument. Well, we would grant that it's not a proper deduction from the argument itself. That is, it doesn't follow directly from the first two premises. It's not directly in the conclusion. But we would say it is a good conceptual analysis that is made. Again, as we've mentioned, the ontological argument before, but we are describing it or using it in terms of a definition. That is, we're making some deductions or some conclusions that are outside the argument that are proper to be made. It's a conceptual analysis of the argument itself. And it's up to show someone, or it's up to someone to show that these are not proper conclusions conceptually to make about the argument itself, or observations about the argument itself. And I think it is valid to do that with respect to arguments. So we'll grant him that it's not a proper deduction from the first two premises directly, but it is something we can indirectly make with regards to a conceptual analysis about the argument itself. The next objection that he makes is that it's a single causal agent does not necessarily flow or does not logically flow. Why couldn't you have a multiple causal number of agents with regards to a conclusion of the argument? Well, this follows the principle we've used here of not multiplying causes beyond that which is necessity. Now, this is Occam's razor being applied here, and most in the scientific community as well as the philosophical community would recognize the legitimacy of this. Remember that our argument called for a single effect, a single cause to the universe itself. Not multiple causations, but a single effect is needed. Therefore, we shouldn't multiply causes with respect to the universe. If we have a single effect, then a single cause is sufficient to explain it. So we shouldn't multiply causal agents without having necessity to do so. The next objection that comes from him says that causality is compatible with an infinite series of events, that we could have an infinite series of events all needing a cause, but I don't think that's compatible at all with this notion of what we've argued for here. It's actually incompatible, and it's incompatible because of an actual infinite, and the past series of events which we've already argued for. This fails to recognize our philosophical argument with respect to an actual infinite in the impossibility of adding an infinite series of causes together. The causality has nothing to do with it, since it would work, or argument would work, even if they were spontaneously and unconnected events with respect to the past. So I don't think this objection gets off the ground or levels anything serious in terms of our philosophical argument that an actual infinite is impossible. Another objection is that if everything needs a cause, then so does the cause of the universe. Atheists would put forward this objection to this argument. But this does not presuppose that everything needs a cause. Again, we did not use the argument that everything needs a cause, or the principle that everything needs a cause. We use the principle that whatever begins to exist has a cause or needs a cause. That being the case, we are not using the principle of sufficient reason as understood in this way. Now, of course, the atheist, we can turn the tide on the atheist itself, who maintains ultimately the same thing about the universe. The classical position of atheism is that the universe is beginningless and uncaused. So even the atheist doesn't use this principle consistently in terms of applying it to the universe, that is, that everything needs a cause. They don't say that the universe needs a cause. So that being the case, we can correct the principle and show that that's not what we used, and that the principle, what correctly stated, is whatever begins to exist has a cause. Now the next objection states that the notion of creation out of nothing, or creation ex nihilo, is incomprehensible, and therefore it explains nothing. Now, by incomprehensible, they may mean that it's unintelligible, or perhaps it's meaningless. But I would assert that that's just not the case. In fact, we wouldn't be having this argument or this debate over the argument if, in fact, it was unintelligible and meaningless. Why debate and discuss something that is unintelligible and meaningless? I think that the problem that's going on here is there's actually a confusion that's taking place. The confusion is between what happened and how it happened. And our argument and what we're able to explain is what happened with respect to the universe. We're not being put forth the notion that we are being able to explain how it happened, just that it did happen. We don't know how it happened, but we do know that it did happen based upon our argument. Just because we cannot describe or even understand how the cause brought the universe into being out of nothing does not mean we can't understand that it did indeed happen. How the universe came from nothing without any cause is actually even more incomprehensible. At least here, we've got something that is comprehensible with regards to the notion of a cause, and even concluding some things about the cause itself. But we don't have to be able to explain the mystery as to how the cause brought the universe into existence. That certainly can remain mysterious, and to a certain extent, we can even say perhaps incomprehensible for our finite changing minds to understand. But again, our argument is more concerned with the fact that it happened, what happened, and the causal agent, knowing something at least about the causal agent that caused it to happen. Again, I think that this objection confuses the scientific explanation, which it is not, with the metaphysical explanation, which it is. Now, we certainly used philosophical and scientific explanations to support our premises, but ultimately this is a metaphysical argument. That being the case, it's not every aspect of it is going to involve a scientific understanding or explanation. What it is going to involve is a metaphysical explanation, which indeed we've given with respect to the cause itself. Again, we don't want to mix the scientific with the metaphysical and expect something out of this argument that it's not going to give us scientifically. So I think if these things are cleared up, this is not a good objection to our argument. So in review of our overall apologetic outline, we're still just at the second point of the outline, which is that the God of the theistic worldview exists. This we've established based on the vertical cosmological argument, being able to match the metaphysical attributes concluded with respect to that argument with the God of Scripture. We've also been able to do the exact same thing with the horizontal cosmological argument, for the theistic God of Christianity is demonstrable because we're able to there also match the attributes of the horizontal cosmological argument with the God of Christianity. So it's here that we have two very strong, undeniable arguments for the existence of the Christian theistic God